This video is on kinematics basics. Kinematics is the study of the whats of motion: displacement, velocity, acceleration, as opposed to dynamics, which is the study of the whys of motion, particularly forces. Forces cause things to move, to change their motion, etc. So that's the difference between kinematics and dynamics, and what we're dealing with here is the whats of motion. Letter B, what quantities do these variables typically represent? D often represents distance. X often represents position. And delta x is a change in position, which is displacement. There are other variables, of course, that you could use for these, but those are typical. And sometimes displacement being a vector, we haven't talked about vectors, but often there will be a little arrow over a vector. So sometimes you'll see that. Sometimes we're a little bit lazy and we leave that off. How about letter C? What variable goes with each of these? Well, speed is v. Velocity is also v, but with an arrow over it. And acceleration, lowercase a. Again, often we put an arrow over it to indicate that it is a vector. Suppose an object starts at x equals positive 30 meters, goes to x equals minus 30 meters, these are positions, and finally ends at x equals negative 10 meters. On our little number line here, our object starts right here, and it stops at x equals negative 10. But before it stops there, it has gone to negative 30. So right here at negative 30, the object is going to turn around. So it's going to start at positive 30, go all the way to negative 30, and then it's going to end right there at negative 10. So what distance is covered? Well, let's see. Can we do this without a calculator? I think we can. From 30 to negative 30, that's going to be 60 plus another 20. So I'm thinking 80 meters. Because of the way it's given in the problem, 30 point meters, negative 30 point meters, that indicates that there are two significant figures here. And when we're adding, we want to make sure that we round, in this case, to the ones place. So it's best really to put a point there. Not that we necessarily have to, but if we're really splitting hairs. How about the displacement? Well, the displacement only takes into account the stop or the final and the start. It makes no difference where it goes in between. So the displacement is going to be negative 10 meters minus a positive 30 meters. And that's going to be negative 40 meters. Let me box that in. Or another way to say that is 40 meters to the left, because you can see on our number line that to the right is positive. Either one of those answers would work out just fine. All right, if the motion of part D occurs over a time interval of 8 seconds, determine the average speed. Speed is distance divided by time. Well, the distance is 80, the time is 8, so speed is 10 meters per second. With distance and speed, we never have a sign. We never put plus or minus. It is just a magnitude, and it's just written without a plus or a minus. On the other hand, velocity is displacement over time, or if you want to say delta x divided by time, that would be okay as well. That's going to be negative 40 divided by 8, which is negative 5 meters per second. Or, said another way, 5 meters per second to the left. All right, let's circle the correct answers here. Acceleration could be positive or it could be negative, because acceleration has a direction. So depending on which way it's pointing, if it's pointing in the positive direction, it's positive. Pointing in the negative direction, it's negative. Speed and distance, those are scalar quantities, and they're always positive, even though they're usually written without a positive sign. They're just written as the number. How about position, velocity, displacement? All of those could be positive or they could be negative. Position, as on a number line, isn't it true? If you're on a number line, you could be at a positive, say, x value, you could be at a negative x value. And velocity is always final minus initial, right? Final velocity minus initial velocity, displacement, final position minus initial. Those could be positive, they could be negative. All right, let's end this video by writing some equations for each of these quantities. The average velocity is displacement over time. What about instantaneous velocity? Let's sneak over here to the right. Well, the instantaneous velocity, I'll just indicate it with a little subscript there, is the tiny amount of displacement that it undergoes in a tiny amount of time. So the delta here on the left indicates a macroscopic amount of time, some number of seconds that you can get your mind around. 3 seconds, 4.9 seconds, 0.68 seconds, something like that. Over here, instead of capital Greek letter delta, right, that's what the triangle is, we write little d's, and that means that those are really, really tiny amounts. Tiny, tiny, tiny. So tiny that you really can't get your mind around it. The same trend holds here for acceleration. The average acceleration is the change in velocity over the macroscopic change in time. The instantaneous acceleration is the infinitesimal change in velocity that takes place over an infinitesimal time. Now, if a problem says find the velocity or find the acceleration, unless it says otherwise, we are talking about the instantaneous velocity or the instantaneous acceleration. And sometimes average velocity and instantaneous, sometimes they're equal to each other. Same with acceleration. Any problem, though, it's assumed that we are to find the instantaneous value unless we're told otherwise.